Welcome. My name's Matthew Gretton-Dann. I am the Toolchain Working Group tech lead. This session is about an LLVM update, which is odd as update for something you've never updated before is sort of here we're starting. It's not an update, it's more we're getting going rather than starting. So the agenda, I'm just going to give a brief, basic one-slide introduction to what is LLVM, introduce the really large team we have working on LLVM within the Toolchain Working Group, talk about what's been done so far, talk about what we're doing next, so in the iteration between now and the next Connect, and then I want to open it to the floor to discuss about future directions. If you're at my previous session that I was doing at 10, you'll see a recurring theme that I'm wanting to get input from outside the Toolchain Working Group as to what matters to people in areas. It's not been very good at getting that previously, so that's what we're trying to get that more public. So LLVM, what is it? It is the low-level virtual machine is what LLVM stands for. It contains the word virtual, but that isn't virtualization as in KVM. It is virtual as in Java virtual machine is virtual. It's a code generation framework, a compiler, so it's a framework. LLVM itself is a framework, so it's not one project. There are many projects using LLVM. There's the core, which are libraries, optimizations, various front ends, a library, and things as linked here. So we have an LLVM team in the Toolchain Working Group that started in January. It is Renato. Renato, do you want to join? And Renato is going to do most of the presenting this morning. He joined in January and is working in the Cambridge office. Yep. So Renato has previous experience in the LLVM community and has been a good benefit to the team already, having made progress on LLVM. So before I hand over to Renato, I'm just going to talk about the goals of the team. So in many ways, like GCC, our goal is to bring good performance, make best-in-class performance out of the LLVM compiler for ARM, for AArch32 and AArch64. So most of the work we do, like GCC, will be back-end focused. We're focused on code generation. We'll do mid-end works where it's more generic, where that would be of benefit to ARM processors. But mostly we're going to be, I call it front-end agnostic. We're not concentrating on improving language features. We're not adding new language features. We'll look at things like ABIs and things which are processor-specific, but we're not going to focus. We're not going to be looking at making sure it's a fully C++ compliant compiler. That's going to be the community. There are other people who are interested in that. That's not our area of expertise. And support the community. Renato will talk about some of the ways we're doing that already, but we're aiming to make LLVM work for ARM. That's how it is. Work for ARM and produce fast code. So I will hand over to Renato to talk about what we've done already, and then we'll start talking about what we're planning to do in the future, and we'll move on to a discussion of what we should be looking at in the longer term.
Hello. So the first thing that we wanted to do is to make sure we actually, not generating code, but generating code that can actually run on an ARM target. And the best way to do this in LLVM is to do build bots, because they already, in the community, that people already care about it. And when somebody commits to LLVM, every commit gets tested by this framework, which means that every commit in LLVM would be tested in all Intel, ARM, MIPS, and all the things. And when something fails, they get an email saying, you broke this build bot, fix it. So that was like free meal for us, because it's just put a Panda board, install build bot, which is not even LLVM specific, is track, and connect to the master, and that was so it was really a quick and good thing to have it. And we were having, so that is the URL if you want to connect to it. And the thing is, it was also that it was just 2 Panda boards, and it used to take 3 to 4 hours to build. And so by the time the build was broken, he would send an email and the guy would be sleeping. And then in the next morning, he wouldn't see the email and delete it or put in the filter or something, so that people didn't used to care about this, especially ARM. But now, because it's always green and because it's fast, sometimes it's 15 minutes, because we did some improvements in the configuration and build, and the cycle that things happen, they fix it quickly. Sometimes when I see it's red and I click on the build and I see that the guy that broke it has already committed a patch to fix it. So sometimes I don't have to do anything. And sometimes I just send an email to the guy, look, you broke the build, fix it. And normally they do. So we don't have to get every single patch and go and debug and etc. The other thing is the benchmarking that we have a way to track. I'll try to connect later and see if I can share some of the web pages. So this it's the build bot, but it publishes all the benchmark results into this perf database, and that produces graphs and regressions and other funky things that you can do with that. And so, for instance, on Friday we had a regression. OGG encoder was failing, and because it was getting on the airplane, I said, you know what, I'll look it on Monday. And then now during one of the talks, I just opened the laptop, let me see what's going on, and it was already fixed. So, but at least now we know, we can track, say, look, the guy broke it here, he fixed it here, this is why it broke. So you have all the data that before we had no idea if it was even running decently on ARM. The third build board is a very, very old, is the first ARM build board. This is several years ago. And it's 926, an ARM 926, that is running and failing ever since it was put online. And then I went to look at it, and it was just silly things like, oh, this is not supported in ARM v5 anyway. So at least now, again, it's green, and it's reasonably quick, 5 hours. And it's yet another build board that we just have it to say, look, we are putting things out and we are testing them, so please don't break them. And what else? So this is, the commits are being tested and the people actually care about it now, which is a good thing. So the other thing we did was to the auto-vectorization it was implemented last year, and this year they said we think it's good. It's because there's one guy that in Apple that he's working solely on this. He has a team working on this, so they're actually improving quite a lot. We get I did some tests, and it gets 50% improvement on LIMPAC for ARM and Intel. So it's really good, and it's so good, or on the tests we test, which is a very small subset, that they decided to turn on by default and let the world break, and then fix it instead of being conservative, because LLVM is not that widely used as GCC, so we can break the world and people just report and we fix it. So that leaves us, the right to break other people's stuff and then work from there. So the build boards and the benchmarks and it's not just a benchmark, it's actually the whole test suite with lots of tests plus lots of benchmarks. And that gives us a good way to know, look, the vectorizer, because in O3, its vectorizer is enabled by default. So at least we know, look, it's not breaking terribly anything, and it's running on a A15 with Neon, so we know it's working, we know it's vectorizing, and we know the results are still good. So the other work I was doing was to implement global structure alias analysis that wasn't So if the arrays were in a global structure, it would just bail out and said, I don't know what that is, so I'll just ignore you. So I was working on this to understand how the middle end works, so then we can change the cost model, because the vectorizer, of course, is mainly done for the Intel backend. So the cost model for SSE and AVX, it's good. The cost model for Neowin is okay. So we need to make sure that we don't break stuff. And the problem is that the cost model is used by both the loop vectorizer and the basic block vectorizer, which are completely different things. And what's cheap for one is not cheap for the other. So we have to make sure that we get the right balance, and we don't break stuff or don't regress that much. What's next? So I had to take out our A15 build board with the Chromebook to put the performance testing. So I want another few Chromebooks, looking at Matt. So to get them running. And we also need from Lava, if there's anyone from the Lava team around, we need models. So we need a new Intel server that running the model in it, because the current server can't take it, to add the 64 build boards. I know it works because Tim from ARM, he did all the tests with the backend that he wrote in the model, so it should work, both tests and benchmarks. Performance, we continue with the vectorization, mainly focusing on the cost model and some other bits, so trying to move towards the backend now, because now I have an idea how the vectorizer works. It's just now like fine-tuning, micro-benchmarking and stuff. And cross-check the loop and the basic block vectorizers to make sure the costs are actually accounting for both styles. And there's also the side effects. It's something that I think the GCC guys are also discussing, is that the cost model is a basic stuff. It's just like, how does this cost? 1. Good. So, and sometimes you say, look, you have a neon, you're moving to neon registers, and then you move back. Or, no, that's a VFP only, it's not a neon. So you have all these cross pipelines that cost a lot of cycles. So you have to say, you have to have a way to say, look, if you're going to do this, that is going to cost you 200 units, because you switch in pipelines or something. So we need to get that into, and I need to talk to someone, I don't remember who was talking to me about how to implement this, how the GCC is thinking about implementing this. So maybe just share the model and do both. More bots, more reporting, and so fine-tune the benchmarks is just look at the generated code and see, getting hotspots and these kind of things. The better reporting and warning system, that was one thing that I'll try to show the graph later, is that the data is in there, but there's no way to query that data and do any analysis on it. You have to rely on the web interface to do that for you. So what I want to do is the guys that wrote this in the first place to at least expose as a JSON or data file or something that I can offline read this, do the checking, like moving averages and standard deviations and stuff, and warn me, like put a yellow saying, look, it's more than one standard deviation, you might want to take a look at this, or the last n moving averages are going up. So you might also, it might be a trend, not a peak or anything. Oh, yeah, that was the last minute slide. We are also helping organize the Euro LLVM conference if any, it's closed for subscription. So yeah, you can't go, maybe next year. You'll be in Paris and yeah, come along. Not anymore, it's full to the top. But next year there will be another one and probably be around in Europe anyway. So we had several papers and it's closed. It was closed on Friday, so it will be quite fun. What's next? So there are plenty of things that we could do, but as what Matt said, we want some ideas from the wider community. What do you guys think we should be working? We have plenty of things that we could do. So one of the things is the integrated assembler. Currently, the default for ARM is to use gas. But there is an integrated assembler that works very well. The problem is that if you have embedded assembly, it won't work because it will be the GNU style. Not also if it's GNU, not the unified assembly, you'll gag. So you do. Ping it. No, he said he has a patch for that. Yeah, just ping the patch. Try again. You know, it's the LLVM, the commits list. It's so frequent, the updates, that you have to bump every 2 or 3 days until somebody picks up. And but feel free to. I have a filter for anything ARM, Neon, VFP related that shows in a separate list. So if you send it again, it will spot in my filter, and then if at least one person review, the other guys, oh, he's reviewing, he's saying it's good, so I have to look to make sure nobody's committing anything wrong, and then it gets traction. The other thing is zero cost exception handling, which is not working on ARM at all. Just the set jump, long jump works for Darwin because the Apple guys implemented, and they don't care about the zero cost. So if it's not a simple thing, because the dwarf model works all right, but only if you throw a simple, without constructors and destructors, simple object, and you catch on the same function, which is not very useful. But that's as far as it goes. Cross-compilation infrastructure is, the command lines are really hard to know. Even I have problems. I always write the aliases because they change slightly over time. So at least whenever it fails, I find out why it failed, and then I just update my alias. So I don't remember what are all the options, but you have to set many things. And so I did a Google Summer of Code project, which is to try to figure out the best way to do this and do it. What else? The big little impact, to see if you guys care about this. This one is a bit fuzzy, because the main interest in LLVM from most of the members and most of the community is OpenCL or render script, all the things related. But we are front-end agnostic, so we should understand IR and stuff. But the IR created by these guys is completely different than IR generated by all the other languages, because these guys, it will come already vectorized, and sometimes with vectors of like 200 lanes, and you have to understand. And normally, a Neon backend, we will just say, look at us, just scalarize this because I have no idea what you're talking about. But then, if you scalarize in the IR level, and then you try to vectorize it, you won't be the same pattern. So you won't recognize the loop as a vectorizable loop, and then it gets worse and worse. So there's a lot of work in the middle end and the back end that could be done to make that work on Neon natively, independent of which one of these guys you're talking about. As a way to actually produce those weird vector sizes and the weird intrinsics to actually produce Neon code. So it depends if you guys think it's important. And that's it.
So thank you, Renato. So the aim of the rest of the session, it's 25 past, so we've got about 35 minutes again. I want to open it to the floor for people to say, does this look like a reasonable list of things to look at? It's what Renato and I came up with, well, actually mostly Renato, came up with, having had some discussions and looking at the current state of LLVM, but actually what matters to you, what are people interested in? Is there something we're missing off here? So Rod, let Rod go.
Yeah, Yeah, so this is very good. Just a quick question. You mentioned OpenCL and RenderScript. Are you also looking at portable native client?
No.
Why not?
Yeah. Because there's too many things, and Pinnacle is not even in high priority for Google. So it might be in some places, but mostly they cared about the render script. There's a group that cares about this, but they had other problems. Like for instance, the IR is so huge that it's actually worse to copy all the things and try to JIT it in and then try to change the code. So they had lots of problems like this, and I didn't see much traction on Pinnacle, so I stopped mentioning. I did in the beginning because I thought it was a really interesting thing. But then they stopped mentioning it. I said, well, you know what? I think they just gave up the idea. Nope. Okay, so it's one interesting thing to do.
Yeah. So I would say that it is, Renato, that is LLVM for us at the moment. So everything will be, we will consider everything, but everything will be a priority list for what we'll have to prioritize everything, obviously. But yeah, thanks, Rod. Zach.
What is portable native client? Never heard about it. Oh no! It's in a public session. What is it? I just want to. I mean, for other people.
Rod, do you want to come up? Or
Thanks. In the land of HTML5, there's still a lot of work to be done to get the performance up. And there's an awful lot of games and things out there already that run on, that are native, written in C and C++. So one way of migrating C and C++ games and applications into the browser so that they can actually run on any HTML5 based browser is using a sandbox methodology where you actually compile your C and C++ in a sandboxed way and actually run it inside the browser, and that's called native client. But that's architecture, it's not architecture agnostic, it's architecture specific. So there's a native client for Intel, there's a native client for ARM. Portable native client actually removes the architecture bit and actually uses LLVM bitcode. So when you actually compile up your application, you compile it to LLVM bitcode and then wrap that as an HTML5 app and then deliver it to the browser. And inside the browser, the bitcode will then get translated to whatever the native device is. So in a nutshell, that's portable native client.
There's one problem with this is that LLVM is not target independent. So the LLVM IR is target dependent. So that when you compile, you have to know to which target you're compiling to. So you can generate IR that will compile on that backend. So because it has all the ABIs and all the fiddling with the return values, and so everything is dependent. So they can't generate portable IR. So they have to have one IR for each target. So when your client says, give me the HTML file for that, you just choose, oh, you're an ARM. Yeah, let me get the IR for ARM. So the benefit was not that big. So they couldn't make it completely agnostic because all the ABIs and stuff. So the last I heard was that, yeah, we had problems with it. We'll look later on. And so maybe they're still looking, which is good to know.
Maybe.
Yeah.
All right, thanks.
Yep.
anything else? Anyone? Let's see. Tas or sorry, Joey.
So how does the LLVM goal connect to the Linaro goal? Be more specific, how will the LLVM technology connect to the kernel or Android or anything related?
So Linaro is about Linux on ARM, and the LLVM is a compilation technology that is being more increasingly used in OpenCL, LLVM, pipe, RenderScript. There are other people I've heard who are trying to build the whole of Android with LLVM. Okay, so that is why it relates to Linaro. It needs to be good. If people are building whole systems based on LLVM, code generation better be up to snuff. up to scratch so that we get good code out of it.
Maybe I should mention that FreeBSD is now built.
Okay, FreeBSD is built with LLVM, but you know.
Yeah, it's side note. It's just that it's a big system, not.
Yeah, FreeBSD is based on x86, right? FreeBSD built by LVM, targeting x86, right? Not targeting ARM.
That's a good question. The guy that is doing this, it's David Chisnell, and he has a good knowledge on ARM, and he's trying to do things on ARM. But the focus for now is still x86 because FreeBSD has some history.
So where can I find more information about the LVM build the whole Android? Who have the more information about?
Zach.
Zach. Good.
And by Zach, he means Sparrow.
So in the past, LLVM did have a very fast changing ABI and API with releases coming up every 6 or 7 months, and with no branch support like, for example, GCC has.
Go ahead.
So currently the Toolchain Working Group is working on GCC branches or provides patches on top of upstream FSF branches. So how is this going to work with LLVM?
The thing is, we don't have any internal branching anything. I work head on, and everything is done in the open. So all the reviews, all the everything, because there aren't many people at Linaro working with LLVM, so I have to get support from somewhere else. But it's mainly because what you said, the API and the code itself, it moves so fast that you just cannot track it. So if you try to track it by release, you're going to break completely in the next release. If you try to track it by month, you're going to break every month. If you track it by week, you have to change your code every day. So it really is a moving target. And for now, there isn't any way that I could find that we would do this. So there was one way which is very complex. Remember we discussing this a long time ago. It was like several things moving and testing and agreeing, and that was the last green thing, but the API was different. The best thing to do, at least for now, at Linaro is work on the head and just submit patches quickly. So it's play the game. Let's
Upstream it first.
Yes.
Cool. Any other comments, questions for people? Let's go for Barrow first, because that's on the way.
It's on the way, yeah.
Are you planning to look into libc++ at all? Because that could really become an interesting project for Android, because it's another BSD licensed STL implementation. Android's STL port keeps falling behind.
That's actually a very good idea. I haven't looked at it because for now we're still trying to define what to do, and libc++ is a separate project and a very young one. So there were other things that I thought about looking first, but if libc++ is a good thing for Android, maybe we should give it a higher priority than.
Yeah, so at the moment libc++ is pretty much untested on all non-Apple platforms, and I've tried to compile it, and there's some promising stuff in there, but it just tends to crash a lot on Linux, so that would really be interesting once it's fixed. And of course, with everything Android, the thing is getting Google to accept it, which may or may not happen, so it's not that much of a priority, but having worked with STL port for a bit, I know that it could really be interesting to replace that, and that might actually be the next big thing.
I think, yeah, it's not just libc++, it's Android, because for now, I was only thinking on Linux and applications, but then I think Android is one thing that we might get it running before than Ubuntu or whatever. So I think it could be a good thing to look first, not just libc++, but all the Android ecosystem.
I'd point out that libc++ obviously is a library. It's not necessarily tied to LLVM. or is it? I don't.
It's not, but it's what he said. It's what Apple is doing.
Yeah.
So it's mainly like all the rest of LLVM.
Yeah. Okay.
Yeah, but still, there's the implicit contract, and mainly Apple's idea of whatever is good and bad. So.
Okay, but yeah, we've got people who work on libraries as well, so it doesn't necessarily have to be Renato. So that could find extra resource in that.
True.
Cool. Hi. Yep.
I'm using the Linaro GCC toolchain to build a WebKit code on Ubuntu, and I want to know when will Linaro will release the LLVM cross toolchain for user.
Okay. So, as Renata's just said, we're not currently releasing Linaro LLVM toolchains because of the way LLVM works. LLVM is at a much earlier stage in its development life than GCC, so it's not that state. Well, the code is stable. The produced code should be producing stable. The code generation should be producing correct code. It should be correct, but the project's not stable, mature enough for us to say that at the moment. And yes, if we would release today an Linaro LLVM, within 3 months we release another, there'd be enough changes between the two that things would be very, very different. And it would require then end user changes to support that. So we're not planning that at the moment. Again, also because it produces a support burden that Renato doesn't have time to handle. We want to get development and performance improvements in there. As the project in Linaro matures up, we get more people working on it, which I hope to do at some point. We'll reconsider, as the LLVM project matures, we'll reconsider, but at the moment we're not planning it.
So there's one thing which is as we've seen in the earlier presentation, Linaro handles 25% of the commits in the ARM part of the Linux kernel. So it makes sense for Linaro to release kernels and stuff. And the GCC team is like half a dozen or more people working on it. So it makes sense because the output is big and it makes a difference, right? But in LLVM, it's mainly understanding what we could do with it if we would do it. So at this stage, it's mainly like asking you guys, look, Android is one thing, the libraries, and Pinnacle might be an interesting thing to do. So we're collecting information. You see, neither Android nor Pinnacle are in my list. So I really have no idea what you guys think is important. I think these are important, but this is just my, very naive view, early Linaro, 2 months in. So I think if you think that we should release something because you need a faster access to a feature that could take, but then it's what he said, the development is so fast that even if we had like 5 people working on it, it would all go upstream. So whenever they release the 3.x, you would get all the features anyway. So they might not even have a Linaro LLVM because we're always working on the head. So it might make sense for GCC or for Linux because they tend to take a longer time to integrate and test and everything. But LLVM is a much easier, much less mature, so you can break stuff more easily, and people tend to be okay with this. So it just goes on the head.
I have a question about LLVM integrated assembler. I have a project. I use the Neon assembly code in the file, but when I compile these files, so I use many ARM directives in assembly file. When I compile these files and Linaro GCC toolchain or Android toolchain, there is no problem. But when I compile these assembly files and iOS, I use LLVM GCC. This toolchain assembler doesn't recognize these directives. So how to resolve this problem? I can't use many directives in these files.
So the main thing is, it was a consensus that we shouldn't try to do anything that is GCC specific. Yeah. So if it's unified assembly, we should support. If we don't, it's a bug. File the bug, we fix. If it's a GCC behavior, then I tend to ask you to continue using gas for that, and because you can interchange between them. You could even say, this file I compile with the integrated assembly, that one, because I know it won't, I compile with gas. So it might have linking problems later, but there's no reason you couldn't flip them. But so if the neon code you're writing is something that GNU introduced, we might not support ever. But if it's like something that is documented in the ARM manuals and everything, then we should support. Yeah. So that's...
I think I can make an example just for directive .qn or .dn. This is resist alias. GCC support this, but LLVM assembler in iOS, this doesn't support. Do you have any plan to resolve this problem?
Yeah. So that looks like a bug.
Yeah, thank you.
Yeah.
Okay. So the best way to approach that is there is a LLVM Linaro project on Launchpad. Just raise a bug on that, or raise a bug in the upstream LLVM Bugzilla.
In the Bugzilla, and point to us the Bugzilla number, and then we fix on the Bugzilla. So
work in the open as much as possible, please.
Yeah.
And just, if you want us to look at something, you've raised it in the open, just copy Renato on it.
Yeah, raise first in the open, then copy me, and then we talk in the open. It's the best approach.
I don't know if there's a similar case in Linux kernel using GCC specific extensions that
Lots.
might not support.
Yeah.
How do you deal with that?
I think the kernel should be fixed.
Hello. The LLVM JIT, I think it's pretty much a platform-independent implementation, I believe. Is there any plan to make it more ARM-specific?
So the JIT, there's two JITs, the old JIT and the new JIT. The old JIT never worked, and the new JIT works all right. And so it works well for Intel, it works all right for ARM, and there are people in ARM working with the new JIT, or at least testing the new JIT. And so it's better supported, but it can't be platform independent. It can't be, because the IR is not. The front ends generate, the most agnostic you can be, it's still target specific. So.
I think, Mons, did you have do you grab a mic?
Well, I was just going to add a bit to what Yang was saying earlier about the assembler. I think she was referring to compiling standalone assembly files, .s files, as opposed to inline assembly. And using various GNU assembler directives in these files. And those are largely not supported by LLVM's assembler for obvious reasons, because it doesn't really need it. I mean, is there a flag to make Clang feed these through gas rather than through its own?
By default, Clang feeds through gas.
Okay, so that should work then.
It should.
Is that right? Were you compiling standalone .s files? Yang,
she's
back
not. Yeah. You compiling .s files, or that was embedded assembly or inline assembly? Just the assembly file. Yeah. So the current behavior is still going through gas. So it should work. The problem that it doesn't is maybe some Clang stupid bug in the, routing the file. But to use the internal assembler, you have to use dash integrated as. Then it would use the internal one. So if you're trying to pass your S file through the integrated assembly, then if it's unified assembly, it should work. But then you have sections and the headers and stuff that it might be, it might not be supported. But I think we should start looking at these issues in the assembler, because I want to turn on the integrated assembler by default. And we can only do, and that many problems that when I sent the email to the list, I want to turn it on by default, and then several people, no, you can't do this because of this, because of that, because of that. Lots of mini problems like this. Like, oh, if I do this, it doesn't even work, even if it goes through gas. So I think we should fix these kind of things. And it goes back to the cross-compilation infrastructure, because sometimes it doesn't find the correct assembler, or it doesn't find the correct libraries to link later on, or it doesn't find, it uses, so if you don't have the target description in the IR, if you cut it out, or if it's just a copy and paste or something, it will just use the host. Even if sometimes you set the target, you will ignore that and use, so there is a lot of problems in the cross-compilation infrastructure.
I think the problem I might, just like the directive aren't be recognized. This is the problem of .qn. When I update the Android toolchain to GCC 4.6, it works right. But for iOS, I use the latest toolchain. It still can't be recognized.
This message, does it come from GAS?
Yeah.
You see GNU assembler, blah, 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 this message.
Yeah.
So then it's not even Clang problem, it's...
You means I use Clang?
So when you use the Clang, do you specify --GCC toolchain?
Yeah. I think only the .qn list directive can't be recognized. There is no other problems.
I think you should open a bug and send me the email, because it looks like a horrible thing.
So I was going to say, can we take that discussion offline?
Offline,
So,
yeah.
Okay,
I think
thank you.
it's too technical to do from 30 feet. Any other questions, comments? Yeah.
I was just wondering how you sync up with Apple, because they're doing so much. I was just wondering how you sync up with Apple, because they're heavily
PST.
involved in the upstream project, right?
What do you mean?
So how do we talk to Apple? Do we talk to Apple about LLVM and what we're doing? Because it involves
Because clearly they're not doing ELF but something else, but they're doing a lot of ARM
So
V7 specific.
they don't sync with anyone. So we it's the kind of dividing the brains. So they have the division internally, the LLVM open source and the LLVM internal thing, and they separate these well. So I only talk to half of their brains, the open one. So it's more a problem for them than for me. When I was working at ARM, it was a problem for both of us. But now that I'm Linaro, my whole brain is open source.
Anything more? Cool. So I hope you've got an idea about what we're looking at for LLVM in the future. As I said, we're just still getting started. We're doing some stuff. Renato's made good progress on buildbots, and that's improving ARM support, making ARM green lots of the time.
Yep.
That's really good progress. We're looking at moving on the auto-vectorization, and when that gets turned on, we'll have good support for ARM in that and good cost models. And then moving on further, and hopefully, well, the aim is for LLVM to be like GCC, that we are producing and we are working to produce best-in-class code quality.
So I have one question. What do you think would be the best way to list these things and get like votes, or people saying I care about this?
Excuse me. So these aren't all ready, but there'll be blueprints produced in Launchpad or.
And can you vote for blueprints?
I don't know whether you can vote for blueprints, but if you have other things, we'll update the blueprints. That'll be an action from this. Come talk to us. Email myself or Renato, make these comments that this is, or talk to your steering committee member and get them raised through TSC or whatever, and we will accumulate who's interested in that. As I keep seeming to say already this week, unless you tell us, we're just going to make it up. So you need to tell us what's important to you, because otherwise we're just going to do what
we want,
what seems important, which will be valuable work because we've got benchmarks against it, but it might not be the benchmarks you actually care about.
Yeah.
We need to know what you care about so that we can make it better.
If you watch the blueprints, the more the watchers, the more important you will be. So it's a way of just measuring interest. If nobody watches anything, you'll just do in alphabetical order. Or
no, but we'll come up with some priority order. Cool. Unless there's anything else, I'm going to draw this session to a close and say thank you all very much.